I thank you who have picked on my talk to have clicked, and I hope to make you glad you came. In this talk I will say to you just how to play in a combinatorial game. So if you have an ear, then you maybe can hear that my words with each other do rhyme, and a promise I'll make is this verse I won't break till the end of this video's time. Oh, and just one thing more that I will say before I begin to kick butt and take names, that the reference that's best, and above all the rest, is Conway's on numbers and games. So now let us outlay the games that we will play. They have two players called left and right, and a bunch of positions along with transitions from one to another which might be labeled with names of the players of games. So when moving from positions where there is more than one choice, one of them you may voice only if your name is there. And then if there's no more place you can go, you have just lost the game you are in, and therefore what you have then made yourself do is allow your opponent to win. So you're trying to stop your one single op from having a move he can make by your move to a place through an option you face that's allowable for you to take. Some other conditions are a starting position, and that games must all come to a close. The time you spend in it cannot be infinite, but no more bounds on how long it goes. It may sound to you crazy game lengths are so hazy, and though you may now feel wary, I will later display a game that you can play, whose length is in fact arbitrary. So with all of these strictures, it helps us to picture a game, but these rules are a mess. So hold on to your pants, because there is a chance what I now say will make you undress. It's the best definition, a great exhibition of simple things being the same as those complicated. Okay, are you sedated? A game is just two sets of games. On the left is the set of positions you let the left player move to, and then the set on the right, as guessed you have might, are the ones the right player can. And so then when you voice the move that is your choice, the game becomes that game you picked. Your opponent then goes in the game that you chose, back to you with the option they ticked. This may be less instructive, but oh so inductive a way to define all these guys. And so now let us see what things there are that we can from this definition imply. In a game we notate the left set and its mate as the left and right options of G, and let GL, GR be the names options are referred to by both you and me. So let's see what does burst from this into place first. There's a simple game we have in sight. Though we yet have no game, a set of them we name. For both options, the empty set right. And now 0 is the name that we give to this game. Let us analyze how the play moves. Whoever goes first's the one doing the worst, since immediately he will lose. With this game we now know, what more games can we grow? Well, of sets of games we now have 2, the empty set still, and one containing nil, and so we can now make 3 games new. So let's study this one, which for right is no fun. If he's first, that is quite a quick loss. And left's first move is tight. When the turn goes to right, the left player still is quite boss. In this other game here, it is also quite clear that it's right who is getting good news. And the last game does play, and yet another way, since whoever goes second will lose. So let's now give some names to these few simple games in which we know just how things are done. This last game is a star, and the other games are a plus and a -1. With these 4 games we've writ, we now have quite a bit of more options that we can now say. There are 16 game sets, and with pairs that then lets us give 256 games to play. And then so on so forth we make games by this course. We say games are born on day n if the nth step's the place that the game does surface, and the first step is the 0th. One more thing I should say about a game on a day. Its options predate its debut, So if you have game G that is born on day 3, then its moves will have days at most 2. And so here's our construction by awesome induction, but more is yet to be defined. We will interrelate the games we've made to date, but let's first say how they are combined. The first thing we do is when of games we have 2, and the sum is what we will now take. The 2 games juxtapose, and when one player goes, in either his move he may make. The way we encode the idea I've just showed is by saying that y plus an x has left options xl plus a y, and as well x plus a yl, and then next, for the options on right, the games that we do cite, are x plus yr, and then 2, xr plus y, so we see that this guy does just what we want him to do. When left picks in this range, just one game does he change of the 2 games we have in our store, and so when he has moved, the effect is what you'd have thought from what I said before. And in just the same way, when right has his say, only one of the games is affected, the other's not changed, and so what we've arranged is again what I before directed. Now, the greatest thing here, which may not yet be clear, besides that this def is so terse, since its statement relies on options of these guys, it means that you have to recurse. And if you have a mind to show sums well defined, to induction you turn, but I'll warn that to make it go smooth, that the n you should choose is the sum of days x, y are born. There are some properties that, if it would please, I will quickly now show they are true. G plus 0 we see is just equal to G, and the same with the order switched 2. Another big one that's immensely more fun is to show that the sum here commutes. By induction we go, and what we did just show is the base case, so let us strap boots. Take a game x plus y, so the options will I now just write out but not name and rhyme. By the inductive bit, all the options we hit, and so we get y plus x this time. And associative 2 is a law that you can extract from a proof by recursion. It is easy to show, but it's messy, and so the proof I'll omit in this version. Now, a problem we've got. Trivial it is not. The sum has no inverse in sight, at least when the game that 0 we name has no options on its left or right. So let's take an odd tack, and this problem will crack by defining the negative first. So a negative game has its options the same as its negative options reversed. And so what is the point of this game we anoint, with the options from players estranged? Well, it plays just the same as the preceding game, except left and right are interchanged. So this means when you take a game and you negate, and you sum up the 2 games you see, the first 2 move will lose by a strategy whose names Tweedledum Tweedledee. When one player does make a move, his opt is take the same one in the other game, and so first is the D, and the dum copies he, and hence is the strategy's name. So the second to go will now defeat his foe, for no matter how player 1 moves, then by taking this tack, a move he'll never lack, and that means that he never will lose. An important point here that was not before clear, we assume there is optimal play, for both left and right. The move that they cite will be best for their own situation. One more issue we raise is we were lackadaisical when we the 0 game wrought, since now with this addition we make the contrition that x minus x is not naught. But this way we negate does for us motivate a new 0 game definition, that the second to go, without doubt we do know, is the one who is going to win. And we redefine too the condition that you call equality of pairs of games. They're equal if their diff is 0, even if they are not so identically same. And in this situation, an equivalence relation is what you can show equals is, and that sums well defined is a proof that is kind of annoying, so let's buy that whiz. By outcome information's a classification of games, and the first are those where the first one to move is the one who will lose. These are zero games, as we declare. For a first player win, the name that we do pin is its fuzzy. The next name we place is if left beats out right, no matter who might make the first move, the positive case. And it's negative then, for the last case here when it is right who will win in the game. And to answer the query, it was arbitrary which got positive, negative names. There are some games that we did previously see that fall into each of these groups. The 0 and star in these two cases are, and plus minus 1, boop, boop. And it's easy then too to see that if you take the minus of 0 or fuzz, the result's the same class, but the same does not pass for the other two classes because, in the positive case, where left player is ace, if you switch the moves of these two clowns, then the right player is boss, so his previous loss is a win, so it's negative town. And for negative things, the same argument sings that it does to a positive go. So the negative sign and these names intertwine in the way we have all come to know. So now games we compare by the condition where, if an x minus y is positive, then the x is the greater of these two potatoes. This is the definition we give. So let's do an example that I hope is ample, comparing a star to a 1. Since 1 minus star is 1 by left by far, the 1 is the greater. Check. Done. I suppose we had ought compare star to a naught, but it's fuzzy the difference we get. So no unequal sign twixt these fits in a line, so games are what we call a poset. Now that we can compare, the next thing that there is to do is make more definition. We define the game 2 as the one in which you, on the left, have a 0 and 1. Now, 1 and 1 more is a game we'll now score. We subtract from this game the game 2. Minus 2 the game's got, minus 1 and a naught as the options that righty can do. So let's analyze play in this game that we say. First, let's see if first 2 play is left. He has 2 moves to do, in this one, and here too, as this game is of left moves bereft. And then right moves in here, and his choice he will steer to the minus 1, cause he does know, that then 1 and 1 less is what we now assess, and here right is the second to go. So when left is the first, then he's doing the worst, and for right first we could show the same. So this game that we're in's a second player win, and that means that it's a 0 game. Now, this may not seem much, but it really is such an important thing for us to do, to show so precisely that sum works out nicely, that 1 plus 1 equals to 2. So we similarly may define the game 3 with a 0, 1, 2 in this place, and for 4 a 3 add, and for n these we pad up to n minus 1 from this base. It's a great exhibition to show that addition for integers works just the same as the ints that we know, but this we will not show, and I hope that you will not me blame. Now, some of you may see that these few games that we have defined are defined in the ways that the ordinals are, and so we may go farther and make games on infinite days. Game omega is defined now in much the same kind, with left options for all n these games. So once left here does move, the game that then you've got an integer from this large range. And this fact we may use to show that right does lose in omega less n for all ints. For when left does his thing from omega, he'll bring n plus 1, which will win for him since, in this game, moves he's got of a number that's not less than n, so for every move right can make n minus n, the left player can then counter it with something that's in sight. Or to make it more brief, right will here come to grief, since the difference is greater than naught. So omega we situate 2 ints and it is greater than all ints we've got. Now, add 1 to this kind of a game, and we find that the options are omega and all n plus 1 games, whose set is the same as the set by all integers spanned. And omega plus 2 in the same way can you scribble out, and this method goes far, because fourth and so on, we may now come upon all the ordinal numbers there are. For now, just one more thing that I'll to your note bring is omega and minus it do, that this game should be naught, and so then we had ought have a strategy for player 2. So when player 1 goes, then an n he has chose, player 2 picks a number that's more, so his op he outlives. The name this Conway gives is My Daddy Makes More Than Yours. So in any case, for now let us just place all the ordinals off to the side, and we'll look at a game with some options we name that between 0 and 1 does it hide. Put a 1 on the right, and on left we will cite just a 0, and that's all we've got. Now this game's a left win, since if he's first writes in quite a pickle when left takes his naught. And when right's first he's done, since he picks out the 1, and a victory left player sees. So this positive game will give X as the name, and lets more information out tease. In game X with 1 less, let us a result press. First, if first to play is player right, then a move he can make is from X 1 to take, so a 0 game we do now cite. And it's left's turn to go, so what we do now know is that right will win if he goes first, and if left starts the game, he's 1 move to his name, and again, he is doing the worst. So this X minus 1 is for left just no fun. It's a negative game, so we've shown, as I did say ago, this game X that we know, between 0 and 1 finds its home. Let us analyze more this game X, so let's score the game X plus X and then 1 less. So let's have left first pick. With 1 option to tick in each X game, we now can express the next position of this game as the 1 with an X plus a 1 negative, and then right can now choose to an X make his move, and we end up a 0 game with. And it's left at the bat, and so we then see that it is right who will win if left starts. Now let's look here again at the game we've got when the left player from starting departs. There are 2 moves that right can first see in his sight. He can move to a 0 in here, but the game that ends ins X plus X, so left wins, so for that option right has no cheer. So then right's other choice is to from an X voice a move to a 1, and so we get X plus 1 minus 1, which again is no fun. It is X, which for right's a poor bet. So initially you've no desire to move, since if so, then on you is the laugh. So this is a naught game, and we've shown X the same as what you might like to call a half. So let's look at game Y, which we will now describe as a 0 and half on each side. We can show it's between these 2 games as we've seen in the X game that we opened wide. And in much the same course, you show this as a 4th, and an 8th and a 16th construct, and the dyadics too are the next thing that you can from these definitions induct. So now what have we done? Well, of games we've a ton, the dyadics and ordinals too, but more generally, we'll define a game G with its left and right options that you can pick out from these sets. Well, maybe let's not say set for a brief interim. There are just too many ordinals so that a set can't hold all of them in. So the term we'll define now is a number. I'm going to tell you just what it is. It's a game where the right options just only might be greater than those left calls his. And additionally, all the options we see must be numbers by this def as well. So again we recurse. By this point in the verse that I love this, you maybe can tell. And it's reasonable to show the number you'll get from writing an A and a B has a size in betwixt the 2 numbers we've mixed to make this one. Additionally, it is possible to show that each number you get you can with each other compare, so that unlike all games where partial order reigns, numbers fit in a line if you care. I have here a quick note that this def that I quote does include all the ordinals too, with nothing on one side this condition that I'd said will vacuously just be true. Now, we take any real and do this here deal. We split the dyadics in twain, in a Dedekind way. So again we now say that's defined in the following train. On the left is the set of dyadics we get that are less than the number we've writ. On the right are those bigger. In fact, we can jigger a way to say this equals it. So these numbers defined, in their very own kind, as a subset of games that we know, as an ordered set do include reals that you may have learned about so long ago. But in fact what is more, and why these I adore, there's a number to which I'll now go. On the left is a naught, and the right side is fraught with all positive reals, and so, well, the first thing to see is that these games that we have put on left and right of this thing are all numbers, and two, they are ordered as you are required to for numbering. So this number we've got, now you see it cannot be a real, for lower bound most of this set on the right is the left set we cite. So this number between is a ghost. So for now we will name this most interesting game, 1 over omega, as theirs, a parallel you'd draw to infinitude of omega. So this name is fair. Now this game times 2 has an interesting view. It is still less than each real plus, and between it and a naught you can see that there ought be another game right there for us. The method that we took to show 1/2 does look like the game with a 0 and 1 can in this case apply, and this game we can spy as a half of this here tiny num. And by similar ways, which I won't with you phase, from 1 on omega we get a whole new real line sitting in this confine between 0 and this real set. Now there is more to do. Between naught and this u can define yet another small game. You may also congeal these two sets of reals and make a game that's not the same. And at ordinals 2, there are real lines u can make disjoint and greater than r. There's so much to explore, but I will close the door on this before I take it too far. But I will just remind, when you think of this kind of a number, these may be sets vast, but that numbers don't sit in a set. They don't fit. And why is that? I'm glad you asked. For example, if we could on right just put the set of positive numbers we get, and on left put a naught, then the thing we have wrought will be positive, not in this set. But by definition, this game we are in is a positive number, and so we did just contradict that a set we can pick in which all the nums positive go. And these numbers we've writ have a name in the literature. They form the surreal line. And remember, on these, there is a sum that we've, in the preceding verses, defined. But just one operations cause 4 reservations in just how much structure we've got. And so multiplication's the next innovation that we will now add to our lot. So the next set of rhymes will now motivate times, and we look at a lemma we've seen, that for left option A and B on right, we say that this game is its options between. Or in other words, G from a GR we see is a positive when G's surreal, and G minus GL is a left win as well, and for H we write out the same deal. We multiply pairs and distribute, and there's a set of NE qualities in which GH relate, and so we can create a new game that satisfies these. On the left first we see GLH plus a G times HL minus GLHL, and the second thing which we then do is to switch every L to an R, and then, well, on the right we now get quite a similar set of options to the ones that we've cast, but one option to star a GL and HR, and GR and HL in the last. Now, I'll plainly confess that this thing is a mess, but the product we just did construct. And as with addition, says the statistician, we'll probably need to induct. There's so much we must show that we think we should know. First, the well definition to do, and although we had saw the distributive law, that is something that we must show too. And this operation is also commutative, and the proof is the same as for sum. And additionally, for surreals we see an inverse for each non-zero num. Now, the proof of inverse, it is not quite so terse, and it's not all that informative. The inverse you elicit is pretty explicit in terms of the options you give. But it's also a mess, and so I will not stress formulae, I will keep them concealed. But the consequence I can still make you espy that the surreals all form a field. Well, not quite a field. The statement I wield is numbers don't form up a set. But, set though they ain't, you remove that constraint, and a field is what you'll get. And just to underscore a name I gave before, there's an exercise I have for you. That 1 over omega and omega bega prove that they are inverses too. All this time that I've spent, and I've scarce made a dent in the study of games as a whole, all we've seen is surreal, so I sort of feel we should turn to another goal. The condition on numbers that it encumbers is making the left less than right. So let's look at the game 1 and negative same, and let's see on what we can alight. So this game will compare to a number where by a plus minus 1 has its bound. So we take now the diff and try to get a whiff of how play goes in this game we found. And with left first to go, it is easy to know that the 1 takes what he had ought. For the game we then gets with the condition met that it's greater or equal to naught. And the turn goes to right, so we pity his plight, for the game that he's got is a loss. If it's 0, he's first, so he's doing the worst, and if positive, left is the boss. So when initially left is moving, we see it's 1 by left, so put on the spin, that instead we suppose that the left second goes, and we similarly have right win. So this game is a fuzzy first player win 'cause he gets to move in plus minus 1. But note in a number that you'd rather slumber and not be the first to the gun, for the options compared to the games are all merde. That's shit in French if you don't know. On the right they are more, so if right moves, the score favors left, and then flipped round also. So this game that we've got, comparable it is not to a minus 1, 1, and betwixt. But if then we do change and look not in this range, and compare, then this problem is fixed. For if x to 1's greater, to right does this cater, in 1, minus 1, and x less. For if left takes as 1, then he still is quite done. So a sign now between these we press. And for negative things, what we'll do is we'll bring in the negative sign from before, and see negative of this game we know and love is the same as this game we adore. So this gives us quite quick, by a proof I think slick, that it's greater than negative things that are not in the range of the numbers that strangely did not to comparing take wing. Now, on the number line, to this game we assign a whole cloud that's related to it, and it's fuzzy in here, but outside it is clear relative to those nums how it fits. For games on finite days, there's a similar haze. They are clouds that have both ends dyadic, and if two things points share, you cannot them compare. If not, comparing is automatic. But a thing you can see is for any game G, you can find out an ordinal big, so that 2G compared it is greater, and there is a small number you too can rig. This large ordinal is just a day, vis-a-vis, the day after the game G is born, for if G is day n, this will mean that then, after n moves, G is of moves shorn. N plus 1 minus G, then for left we can see, is a win, for at each of left's moves, he'll go in n plus 1, and when game G is done, then the left still has something to do. And the negative this is the bound that we list on the negative side of game G, and so any game can, by a cloud, have its span, and this cloud has two ends that we see. So that's more craziness in these games I profess, but we see how the post set's arranged, which games interrelate, and which games we can state are from other games nearby estranged. So let's return at last to a game from our past, the star that we from before know, that it's fuzzy with naught is a thing that I taught, so to other numbers we will go. For a positive x that's a number, we'll check that x minus star's a left win. If left goes first, he goes in game star, and we then get x, which in that puts a pin. And when right's first to move, if in x he does choose, then his xr is positive, thus, if left goes in star, then left wins, so r must make this move. That's disastrous. So this game star we've got is a cloud all at naught, as it's comparable to the rest of the surreal line, as what we did just find also works for numbers to the west. Now, this star is interesting. The options of this thing on both of the sides are the same. We can generalize this fact, so I'll advise that what you get are impartial games. The def goes as thus: the two sets you have must be identical, and then, as well, just impartial games may be the options if they, and this type of def might ring a bell. But in any case, now here in this place, since the two sides have options the same, all these games we may cite by one set, and we write just that one set to define the game. Note the game with a star as the options there are is won by that player who's not first polled, since the first player moves to the star, and then 2 moves to 0 and picks up the gold. But a new game star 2 can be written by you as the game with a star and a naught, and to get a star 3, add star 2, and you see, there's a pattern we have again caught. So each ordinal has an impartial game as a star with a subscript of that, and each game has a cloud that may not be allowed to be different from where star's cloud sat. Now, the difference of 2 of these games that you view is a fuzzy game, since first to pick, in the larger star can pick the smaller one and go to naught, so his op he does lick. So again, not a set of impartials, and yet they all fit near to 0 in line. These are also called nim, but I'm about to finish so I won't spend on them more time. Because there are more games that don't work quite the same as the games that we all have now faced. So the next we consider is another small critter, with naught and star in left-right placed. With the left first to go, he picks 0, and so then he wins. And if right's first at bat, to a star he moves, and then the left has command as he goes to a 0. That's that. But if we're a bit wise, we can now analyze and get that this is less than surreals if greater than naught. So this game we have brought into being has quite a strange feel. On the number line it has no cloud. It does sit in the gap between naught and the bigger. And with star it has fuzz, which I won't show because that is something that you can outfigure. And now up is the name that we give to this game, and its negative we may call down. There's a whole other tale of games on this scale, but that's about the time I've allowed. So I thank you for hearing my, I hope, endearing talk touching on games of this sort. And please like if you'd care, and if you'd link and share, I'd appreciate all your support.